Building a Dyson sphere around the sun and harnessing all of its energy is a far-fetched dream for many of us. However, in reality, a developed civilization of the first type, according to the Kardashev scale, could succeed in constructing this megastructure. Judging by recent evaluations, we're just as far from this goal as hunter-gatherers were from building a nuclear power plant. To close this gap, futurologists have suggested various extraordinary projects, such as filling our Earth with millions of diamond balls, launching giant hexagons into orbit, or moving half of the population underwater. But can humanity really achieve the status of a Type 1 civilization on the Kardashev scale, or is it beyond our grasp? To even have a chance of raising our civilizational status, we would need to accelerate our technological progress to a potentially dangerous pace, according to many scientists. But how advanced does humanity need to become? In 1964, Soviet scientist Nikolai Kardashev developed a special scale, according to which all intelligent civilizations should develop. The level of civilizational progress depends on the amount of energy a civilization consumes and produces. The original Kardashev scale has only 3 levels: a Type 1 planetary civilization, a Type 2 stellar civilization, and a Type 3 galactic civilization. Thus, if we want to become a Type 1 civilization, we must produce as much energy as is generally possible to obtain on Earth, including both planetary sources and solar energy reaching us. According to the Kardashev scale, our current level of development is at approximately 0.75. This may seem close to Type 1, but the Kardashev scale is not linear, it is logarithmic. This means that the closer we get to the end, the more energy is needed to move forward and reach at least one full unit. So with a level of 0.75, we actually have only about 2/10 of the total energy that a Type 1 civilization should produce. To move just 1/100th up the scale, we need to start producing 25% more energy than we do now. But how can we achieve such a powerful boost? Recently, a team of researchers from the Lawrence Livermore National Laboratory, along with the Japan Aerospace Exploration Agency, proposed an intriguing solution, a project called COPIA. This involves immense hexagonal mirrors located in open space, which would reflect and redirect solar energy to satellites equipped with solar panels. These satellites would then convert the energy into radio waves and transmit it to Earth, where rectifying antennas would convert it into electricity. According to scientists, even one such installation could completely replace several terrestrial nuclear power plants. The most exciting part is that, according to Martin Soltau, chief executive director of the project, the energy generated in this way could be almost infinite. For mirrors placed in a certain orbit, the sun would never set, so the final energy output would depend only on the number of such installations. So far, this project is purely theoretical, but governments of leading countries are ready to allocate over $10 billion for its implementation. However, not only will each new mega-project like this bring us closer to a Type 1 civilization, but it could also put us in danger of complete extinction. The reason for this is the Great Filter. The term Great Filter was first mentioned by scientist Robin Hanson in 1996. In his opinion, the faster a particular life form evolves, the more dangerous it can become. Although it seems that people have been around forever, in fact, on a cosmic scale, the formation and, most importantly, the technological development of humankind have evolved extremely quickly. After all, the universe is already over 13.5 billion years old, while intelligent humans appeared only 300,000 years ago, a mere fleeting moment on a space scale. Hanson believes that now we're evolving faster than ever, which means we risk facing an insurmountable obstacle that could lead us not to the first type on the Kardashev scale, but to a tragic end. This is what the Great Filter represents. Today, we're already surrounded by many potential disasters, from an uncontrolled greenhouse effect to the dangers of extreme AI development. But how is this related to space mirrors? Jovana Radulovic, Doctor of Sciences and Professor of Thermodynamics at the University of Portsmouth, calculated that the carbon footprint from launching the COPIA project would be 100 times higher than the emissions of all our industries and transport combined. It's a strange paradox. To obtain clean space solar energy, we risk further damaging Earth's already fragile ecosystem. Does this mean that on our path to becoming a Type 1 civilization, we shouldn't heavily rely on new mega-projects with unexpected consequences? perhaps we should just continue using the energy sources we're accustomed to today. About 70% of Earth's energy needs are still met by coal, oil, and gas. However, the problem with natural resources isn't just that they pollute the atmosphere with chemicals and carbon dioxide, they're also running out. Moreover, according to the latest research, it's happening much faster than we initially thought. Experts from the Geodetic Institute of Slovenia have calculated that if we maintain the current rate of production, Earth's reserves of coal will last only another 133 years, while oil and natural gas resources will run out in 50 years. Even if we try to increase energy production from traditional sources, this will bring us closer not to a Type 1 civilization, but to a civilizational collapse. So, the old energy sources can no longer be relied upon, but there's still no adequate replacement. What's more, a study published in 2015 in the journal *Science Advances* states that such an extreme move would literally lead to a great flood. If we burn all the fossil fuels left on Earth, the ice in Antarctica will almost completely melt, and the world sea level will rise by as much as 60 meters, flooding half of Europe, all island countries, and most coastal cities worldwide, resulting in hundreds of millions of victims. Currently, we don't only rely on natural resources but also on nuclear energy, which today helps produce about 15% of the world's electricity. The solution seems obvious, we just need more nuclear power plants. However, after the disasters in Chernobyl and Fukushima, many progressive countries like Italy, Germany, and Belgium have closed their nuclear energy programs, despite the fact that with each passing year and new technological discoveries, the likelihood of such catastrophes is decreasing. Yet, this type of energy still poses a number of serious problems. It's essentially a time bomb. We can hardly dispose of radioactive waste, instead, we simply store it, hoping that future scientists will come up with a solution in the next 1,000 years. Moreover, even if we cover all available sites with nuclear power plants, it would only move us forward by less than 0.1 on the Kardashev scale. To progress even a little further, we would need to put nuclear power plants everywhere. An alternative solution could be another type of atomic energy, the thermonuclear fusion of hydrogen into helium, which releases a lot more energy, 138 mega-electron-volts in a thermonuclear plant versus a mere 172 in a conventional nuclear reactor. Additionally, there's practically no toxic waste left from thermonuclear fusion. Inspired by this, Troy Carter, a physicist at the University of California, developed a system capable of entirely converting the United States to fusion energy. Such reactors can be 10 or even 20 times smaller than conventional nuclear ones, while producing as much as 8 times more energy. If the entire country were covered with a network of interconnected fusion reactors, most industries would no longer need additional electricity. Unfortunately, this project isn't possible yet. Every fusion reactor built so far consumes more energy for its own launch than it produces as output. But you might ask, what about the recent big breakthrough announced in December 2022 by experts at the Livermore Laboratory? The press release said that with the help of powerful lasers, they managed to get about 3 times more energy than they used to start a thermonuclear reaction. In reality, this isn't entirely true. If you count not only the energy in the reactor but everything needed to run the lasers, you'll find that more energy is consumed than the entire United States uses. The energy released was 1,000 times less than claimed, and the reaction itself lasts only 1 picosecond, often leaving scientists without enough time to capture the released energy. Even with today's best technologies, if we build a network of thermonuclear fusion reactors, all the world's electricity wouldn't be enough to launch it. So, should we look for the key to advancing on the CEV scale in other technologies? Nowadays, we produce about 11% of the world's electricity turnover using alternative sources, with hydropower leading among them, accounting for as much as 7%. Nevertheless, it's clearly not enough to cover all earthly needs, let alone surpass them. Even if we manage to launch 5 times the current number of hydroelectric plants, wind generators, and solar panels, our progress on the Kardashev scale would be almost unnoticeable. It turns out that the only way forward is to constantly improve existing technologies and squeeze the maximum out of them. One way is to extract energy not from the sun, but from the moon. This, of course, isn't about the weak light of our satellite, but rather its gravity, which causes powerful ocean tides on Earth every day. Their energy is literally wasted. To gather it, we need to build exotic stations near the shores with light underwater propellers that turn every time the water moves toward or away from the coastline. According to scientists, the power of one such station can reach 300 megawatts, enough to power over 200,000 homes. If we manage to fill up all the available coasts with such stations, we could advance along the Kardashev scale by about 1/10. Still, this wouldn't be enough. What if we also connect underground energy sources? Approximately 44 terawatts of heat constantly migrate from Earth's core to the surface. With this amount of geothermal energy, you could warm as many as 750 million homes. To begin using such a resource, we need to drill wells at least 2 kilometers deep in suitable places and then heat the water with jets of hot steam. This steam can be passed through special turbines that rotate to produce electricity. Perhaps with this energy, we could accumulate enough to launch thermonuclear fusion, and the ocean could provide an almost endless source of fuel for it. The oceans contain enough hydrogen to convert matter into energy at a rate of 2 kilograms per second. With such reserves, we could produce electricity for several millennia without needing additional sources. If fusion stations are placed right in the ocean, their launch could be easier due to tidal energy. Scientists still need to figure out how to accumulate a large amount of energy in a short period. If such technology could be developed soon, we might significantly approach the status of a Type 1 civilization, harnessing the energy of the oceans and Earth itself. But how do we close the last gap? In 1973, American astronomer Carl Sagan developed Nikolai Kardashev's ideas, reasoning that a planetary civilization of the first type would be able to confidently control any natural phenomenon. Tsunamis, tornadoes, and earthquakes would become just additional power banks, and humanity could soon come close to such power. In 2010, scientist John Storrell suggested the concept of a weather machine. This machine is a set of microscopic, transparent balls, each varying in size from a millimeter to a centimeter. Each ball consists of the thinnest diamond shell, no thicker than a nanometer, containing a mere membrane and a tiny control unit. This unit helps tilt the device in different directions. Millions of hydrogen-filled balls could envelop the entire planet in the stratosphere, about 30 kilometers above Earth. Remote control would allow entire drought-prone regions to be shaded, while also reflecting and redirecting light to areas where it's lacking. Excess solar energy could be converted into radio waves and sent to Earth, significantly increasing electricity generation and dramatically optimizing its costs. Unfortunately, John Storrell's ideas weren't widely accepted in the scientific community, as they seemed too unreal to the experts. Recently, however, researcher Robert Fries revisited the concept of a weather machine and concluded that it might actually work. The first test of this model on a small scale is planned for 2032. Still, skeptics warn that such manipulations with the atmosphere could lead to unexpected climate changes, potentially even causing an ice age. We'd certainly like to avoid such a great filter. However, even if the weather machine works and brings us closer to a Type 1 civilization, it's not a happy ending yet. In order to not only become a Type 1 civilization on the Kardashev scale, but to maintain this position, we'll need something radically new. How about extracting energy from things we usually don't pay attention to? In 2019, a group of Filipino research students presented an unusual device that could generate power from city noise. It turns out that an ordinary metropolis can produce up to 1.12 megawatts of energy with its sounds, similar to your average thermal power plant. While noise pollution could power neighborhoods, ordinary trash could power entire countries. Every year, plastic production increases by millions of tons, but only a tenth of this amount is subsequently reused. What if instead of recycling garbage, we tried extracting energy from it? Alas, the most obvious solution, to simply burn plastic and get heat, failed miserably. Burning plastic produces 4 times more greenhouse gases than the rest of the energy industry combined. By burning garbage, we would bring the Great Filter down on our heads even faster than if we continued to produce energy uncontrollably. Still, humanity has a chance to both clean up its waste-filled oceans and start fresh with pure energy. Pyrolysis, a process of controlled decomposition of chemical compounds, was once believed to be applicable only to organics on an industrial scale. However, in recent years, it has been successfully used to decompose plastic. In the pyrolysis machine, plastic is decomposed by heat in a vacuum, so no smoke is emitted. The resulting chemicals can then be used as feedstock for fuels and other products. So far, such installations are used only in some industries, but in 2021, Italian scientist Sabino Arman, together with his team, proposed a concept that could make plastic pyrolysis genuinely global. If people, in addition to all previous innovations, managed to recycle all the garbage floating in the oceans, we would reach a Type 1 civilizational status in no time. Moreover, in purified water, it would be possible to build energy-independent cities of the future, which is essential for any civilization of the first type. The Ocean Spiral project of the Japanese corporation Shimizu is designed for thousands of inhabitants and doesn't require substantial energy costs. This floating sphere, 500 meters in diameter and located just below the sea surface, would house business and residential areas, hotels, gyms, gardens, and cinemas, everything a person needs for a comfortable existence. This capsule would be connected by a 15-kilometer spiral path to the ocean floor. For such a metropolis to function, there wouldn't be any additional energy resources needed. After all, the bottom of the ocean is much closer to the magma, so if you drill a well just 1.5 kilometers deep, the heat from Earth's crust could solely cover all the energy needs. Perhaps drilling won't even be necessary if humanity masters another energy source an order of magnitude more powerful than thermonuclear fusion, antimatter. Antimatter is ordinary matter with all its parameters inverted. The main thing is that when corresponding particles collide, matter and antimatter destroy each other in a powerful flash. The energy released in this process is approximately 250 billion times greater than that of fusion power. Just 1 gram of antimatter can produce over 52,000 megawatts of power, enough energy for 40 million homes. There is one problem, though: it's almost impossible to get antimatter on Earth. That's why engineers didn't even consider antimatter power plants until the scientist James Bickford suggested mining it in space. To do this, we would need to launch 2 coils of high-temperature superconductors beyond Earth's orbit. The coils would be powered by solar energy, creating a magnetic field, a trap for antimatter. Hypothetically, in just one day, humanity would be able to receive 20 times more energy than we produce now. It seems like the issue has been resolved, hasn't it? But antimatter hides a danger that may turn out to be yet another great filter on our way to becoming a civilization of the first type. American physicist Robert Forward suggests that matter and antimatter in the universe should balance each other proportionally, and if you extract a lot of antimatter from space, this balance will be ruined. Recently, scientists found that Earth's magnetic field is already attracting some amount of antimatter particles to itself. If we start mining antimatter near Earth, this could affect the functioning of its magnetic field, potentially leading to its complete disappearance. Then, the charged particles of the solar wind would hit all the electronic devices on our planet, which no one would really care about because they would soon become unnecessary anyway. Indeed, without the protection of the magnetic field, mobile communications and the internet on Earth would also disappear, leaving humanity to suffer a painful death from radiation sickness. Instead of reaching Type 1 on the Kardashev scale, we would drive our civilization back to zero. Nevertheless, some scientists believe that not just technological difficulties or potential great filters will get in the way of our dramatic energy breakthrough. It's already clear that we can't become a Type 1 civilization without certain mega-projects, but in today's world, only autocratic societies can implement something like this. Let me remind you of the record-breaking skyscrapers and artificial islands in the United Arab Emirates. Unlike democratic countries, in those states, governments simply don't ask their citizens what to spend money on. On the other hand, Carl Sagan was convinced that humanity could become a prosperous Type 1 civilization and maintain that status only with the absolute equality of human rights and democracy globally. But how many people would seriously vote to spend their entire year's budget on hexagonal mirrors or go without electricity for a few days to run fusion networks? So far, it's hard to find a solution to this paradox. Do you have any ideas on how to organize humanity to reach Type 1 on the Kardashev scale and achieve the dream of a Dyson sphere?